So these would be vectors whose magnitudes are 1 and they are in the direction of the positive axes. If you're in R2, then we have two of them. It's vector. We call it vector I and vector J. So in R2, there are two of them. And we would call one of them vector I. I'll write it that way. I can write it I with the little hat on top. And vector I equals 1, 0. Vector J, I can write it with the arrow. I can write it with the hat. J would be 0, 1. And most of the time, I don't dot the I and the J because it gets too cluttered. I did write there, and I don't know if there's any protocol on that, but most of the time, I don't dot them. All right, if I sketch these, here's my XY, and I'm going to put 1 kind of far out. So I would be in position form right here, and J would be along the y-axis. So vector I and vector J. And it does not matter to me if you use the hat or the arrow. It doesn't matter. If we're in 3 space, you have 3 of them. So in R3, we have I, which would be 1, 0, 0, and J would be 0, 1, 0, and K would be 0, 0, 1. And I'll go ahead and sketch these for you. So I'm going to have the y-axis kind of coming at an angle, and the x-axis as well. Z-axis going straight up. And I'm going to put, I'll mark 1. I might even mark 2 on the x, but we're interested in where the 1 is. Positive 1. Now what's this point? That would be 1, 0, 0 on x. And I'm just kind of marking where the 1 is on the number line, but maybe this one on the z-axis, the coordinates are 0, 0, 1. I along the x-axis, J along the y-axis, and K along the z-axis. So I, J, and K. So the standard basis vectors. With this, I can also write vectors algebraically. I can use my angle brackets, or I could use the I and the J and the K in whatever space you're in. So I'll do an example So I have negative 3, 7. I could actually write this vector as negative 3 times I plus 7 times j. And in my old notes page, I did a little proof of, yes, that really is accurate, because I could say, okay, this is negative 3 times I. Now I'm in 2 space, so I is the vector 1, 0, and j is the vector 0, 1. And now I'm using the properties of vectors that are given in the book. I can take negative 3, which is a scalar, multiply it into the vector 1, 0. I'll get negative 3, 0. And then I can multiply 7, which is a scalar. Oh, that's going to be 0, 7. Then I'm adding 2 vectors. I can just add the corresponding components, negative 3 plus 0 and 0 plus 7. And I get vector negative 3, 7. And it almost feels a little silly to have done that, but just kind of showing that you can write the vectors either way.
Dr. Matt?
Yeah.
So for our standard basis vectors,